This is Mr. Taylor. We want to talk about dilation, more so 8.3b, where we compare and contrast the attributes of a shape and its dilation on a coordinate plane. As with all of our lessons, we want to make sure that we get a good grasp, a good understanding on these definitions, and also the actual rules and concepts that's applied. So to get us started, let's talk about some definitions and what we're required to know. We do know, all of us, that when we talk about a dilation, we're talking about a transformation. And this transformation is something that causes a figure or an image to either enlarge or it will reduce. The particular transformation depends on the scale factor. Scale factor is some number that we're going to use to make our figure enlarge or reduce. The angles of the original figure and the dilated figures are congruent. Let me repeat that again. The angles, the inside measure of the original figure and the dilated figure are congruent. This is simply just saying that when we look at a figure on the inside of that figure, these angles, regardless of whether it's enlarged or reduced, will be the same. It also wants us to know that the sides of the original figure and the dilated figure are proportional, which means they will create similar figures. When we enlarge a figure, then we're taking a scale factor, and the scale factor just means some number that we're going to multiply by. We're going to take this scale factor, but this scale factor has to be greater than 1. When we reduce a figure, then the scale factor has to be roughly a fraction or a decimal between 0 and 1. And of course, if we want the actual figure or the image to be the same, we say that that figure is congruent and we have a scale factor of 1. Now there's some prime notations that we need to be concerned about of the image points. So these notations are called prime marks. So here's an example. My original will always carry something, and these are the actual vertexes, A, B, C, or D, and it will carry no prime notation at all. So when we see A, B, C, or D, we're talking about the original figure, which we also call the preimage. And if we see A prime mark, B prime mark, C prime mark, D prime mark, then we say that this is the image or the new figure, okay? And pretty much is read A prime, excuse me, B prime, C prime, and D prime. We'll use the coordinate planes for dilation. We're going to use all 4 quadrants. Okay. When we dilate, we create similar shapes. Similar shapes are shapes whose angles, the inside, are congruent and their side lengths are proportional. That means that they have a scale factor that's going to be multiplied by every single side length, and that scale factor is going to be the same. The order of the letters determines the corresponding side lengths and angles. We get to that in just a minute. So when we look at the notations for similar shape, just like we have the prime marks, we have notations for similar shape, and it's this little squiggly mark. And it's just simply letting us know if you see this, then it is read, for example, A, B, C, and D is similar to A prime, B prime, C prime, and D prime. So that should let you know that we either have an enlargement or we have a reduction. So since we're talking about similar shapes, let's look at some attributes. And we want to know that similar shapes have corresponding sides and they are proportional. Similar shape has corresponding angles and these angles are congruent. Now we just talked about what that means when we say congruent. It just means that they are the same. So now we want to get into a quick example and take this example and see what can we create. Now notice it gives us a figure. The figure in blue is the original or the pre-image. The figure in blue. Now we can read this as A, B, C, D. Now the shape itself tells me that it's a parallelogram, mainly because we have two sides that are equal here and here, and we have two sides that are equal here and here, and we're talking about equal in length. So it goes on to tell us that this parallelogram ABCD is dilated to give us A prime, B prime, C prime, and D prime. So we have a smaller figure that has been enlarged. So we have a dilation, and it's the smaller, the original figure has been enlarged. So part A tells us, well, it is asking us, look at this figure. Here you're looking at the figure and you want to answer two questions. The first one, what generalization must be true about the side lengths and angles of this particular parallelogram and its image? So what generalizations must be true? So when we mean by generalization, we're just going to take not a theory per se, but we're going to take some characteristics, some general characteristics, and see what these two have in common. And then part B says we want to verify them. And we want to verify these generalizations by using, and it gives us an angle. And I'm sorry, well, they do give us an angle, but they also give us a side length, and they're giving us length BC. So this is line segment. That's what that means. They're giving us line segment BC, and they say that this line segment is 3.16 centimeters. And then they also tell us that the length of B prime, C prime is 9.48 centimeters. Then the third thing they're telling us is that we have angle A, which is this part, and it tells us angle A has a measure of 109 degrees. So they're telling us first, part A, make a generalization. Part B is to verify these particular generalizations that we made. Okay, look at how the response will be. So, as we said earlier, the side length of a parallelogram, ABCD, are proportional to the corresponding side length of the parallelogram. It is a dilation. It is an enlargement, so they're not equal. We know that we use a scale factor, and if we use the scale factor, then, let's see, we're talking about a scale factor that's greater than 1. So we have to use the scale factor. I'm going to use SF. And the scale factor is greater than 1. And we know that because it's an enlargement. Okay? So another generalization we can say, and we want to use this to talk about the angles, we can say all angle measures of this parallelogram are congruent. That's what they told us in the beginning. They said that the angle measure of a dilated figure is the same. All right. Well, we made our generalization, part A, now, and notice we did generalization about the side length. We did generalization here, and we also did generalizations about the angle measure. So let's go ahead and verify it. So in order for me to find what they were telling us, remember they told us that BC equals 3.16. Then they says B prime C prime equals 9.48. Well, there's a sense to the madness. What you do in order to find your scale factor is you take the new and divide it by the original. So that will give me 9.48, and you use this in all particular examples. 9.48 divided by 3.16. This is the original, and this is the new. So when you divide that, you will get 3. Okay? So if I'm getting an angle measure of 3, and now this is telling me that side AB, and we can go back to our graph to prove it, that side AB, or should I say segment AB, has a length of 4, BC 3.16. Well, if it's a parallelogram and we have these, so if this is 3.16, then the other side must be 3.16. So it tells us that this is 4. Then guess what? The other side must be 4. Because in a parallelogram, you have two sides that are equal. So this is what it's saying. This is exactly what the proof or the verification is saying. AB is equal to 4. CD, which is the other side, is also equal to 4. BC is 3.16 and DA is equal to 3.16. Now, in order to get the new, which is the image, we multiply this by this scale factor that we just divided by this ratio to get, and which is 3. Multiplying 3 by 4, you get 12. We already know 3 times 3.16 is 9.48. And of course, 3 times 4 is 12. So we prove this part, that the side length of this parallelogram are proportional to the corresponding side length of the image. Now we need to look at the angle measure. So this is what was a little distance for us in class, is we looked at this angle measure and we saw, and I'm just going to draw this small one, if you don't mind. And it tells us that this has an angle measure of 109 degrees. Well, we know that a line carries a 180 degree measure. So that means if this is 109, then what is this angle? Well, this angle will be 180 minus 109, which is 71. Now, you should recall that angles that are opposite are congruent. So the opposite of the 109 angle is this angle here, which will also be 109. And the opposite of this angle, which is this angle, is angle here, which will also be 71. So this is how we got angle A, 109, angle B, 71, angle C, which is opposite of A, 109, and angle D, which is opposite of B, 71. So we can use a little bit of knowledge and go ahead and prove or verify what we had generalized in the beginning. But it's actually still the same identical concept. Okay, we've had a little inconsistency with this lesson today, very short. We are concerned with how we transform by dilation, but we're more so concerned with how do we compare and contrast these. And this is what this lesson was intended to prove to you. Okay, this is Mr. Taylor, and I'll talk to you soon. Remember, if you have any questions at any time, please comment via the comment in the classroom, Google Class, or you can bring them to class with you the next day. I'll talk to you soon. But if I was you, I would you could stop it and go back and see, can you